which is P times the diagonal matrix, which elements contains the eigenvalues, times B minus 1. And I can get the inverse of this matrix very easy if I want to. If you remember how to get an inverse of a 2 by 2 matrix, it's very, very simple. If I want to get B minus 1, it's gonna be 1 over, just multiply the elements of the principal diagonal, which is gonna be negative 3, minus 1, so it's gonna be minus 4. This is minus 3, minus 1, minus 4. Then I will change these two numbers, so it's gonna be 3 and the negative 1. And they change the sign of the sides, so it's going to be negative 1 and negative 1. So the inverse will be simply 3 over 4 with a negative. Then I will have 1 over 4. Also, I will have 1 over 4. And for the last one, it's going to be 1 over 4 also for the inverse if I want to evaluate. Please do check the signs. This is negative, this is positive. I believe this is also positive, and that one is positive. This is going to be the inverse of this matrix. Okay, perfect. The second step, he's telling you, or the required after that, he's telling you what's going to be the steady state or the percentages, overall percentages of countries that will change. And in this case, if I want to get the result or to the bottom of this issue, all I have to do, just wait a second. I'm sorry, I have a problem with the batteries. As I told you, for number C, is asking you in the long run, what's the percentage of total countries that are democratics, which means I will take limit for the n times, or for the time n. So all I have to do is to get this value, 0.6 to the power of t, 1 to the power of t. This is the main actual, this is the main advantage of using the eigenvalues or diagonalization. So I will take the limit of t tends to infinity of xt, as you see in the next slides. So t tends to infinity, a to the power of t times x naught. So I will replace a with b minus 1 to the power of t. So it will be p d to the power of t b minus 1 times x naught. Similar manner, if you try to take t up to infinity for this matrix, you will have 0.6 to the power of t and 1 to the power of t. So once you start taking the limit t tends to infinity, this value will approach to 0, 0, 0, and 1. Once you use this for the infinite number, and you do your multiplication, as I told you, you will end up having 25 by 75, which is the result that he asks you about. Okay, perfect. Just a second. I will have to replace the batteries with my pen. Wait a second, please. Yep. Now we are working in a perfect condition. Okay. Okay. For this problem, which is group number 5 or problem number 5, which about vector spaces, as you can see, it's asking you let V be a span of U and V with U2, 3, and 1. V is negative 2, negative 1, positive 1, and consider the vector W, which is double 1 and 0, for Z, which is ABC, with ABC belongs to R. For point number A, write the vector W as a linear combination of the vectors U and V. So let's start writing the vector W as a linear combination. This is very, very simple. All I have to do is write W equal A1 dot U plus A2 dot V. Solving, and we will have to solve this system of equations. So all I have to do, as I told you, that I will get for W which is 1, 1, and 0, and it's gonna equal to u and v. So it's gonna be alpha, for example, times u plus alpha 1 plus alpha 2 times v, just to make the substitution and solve your system. So the result will be a quarter of u minus a quarter of v. Okay, I hear. Okay, I will do this once, this time, in details, just to make things easier for you. Now, for these two systems, I have on a matrix of an augmented matrix, u1, which stands for this vector, which is 2, 3, and 1. The v, which is -2, -1, +1, and they should equal to the w, which is 1, 1, and 0. Try to get to the reduced echelon form, and once you get to the reduced echelon form, you will find that the values, this is the column of alpha 1 and alpha 2, you will find that alpha 1 equal 1 over 4, and alpha 2 equal -1 over 4. These are the values of the coordinates. So just to try to solve this system of equations, it's really, really simple. You can divide the first row by 2, and then multiply by -3, and then -1, add on the last row. Okay, you will have a just only one row by the end of your process. I believe it's going to be 1 like 4 equal to 0, something like this. So once you try to work it out, you will have one of them as a quarter of the other, and you will get your solution or the form of these quantities. Okay. The second row is stating that find the set of values for ABC so that Z belongs to V. As I told you, this is the solution. So also for number B, I will consider vector Z to belong to the V set. It has to be a linear combination from U and V. So all I have to do, once more, is write Z, which is ABC, equal some value times U plus some value times V. And then I will try to solve a system which contains ABC equal lambda of the first vector, delta of the second vector. Using this, or trying to solve it, you will end up having this system. Use any method that you like. This is going to be solved either by reduced echelon form, do an elimination, whatever. Then I will find that you will find the condition for the ABC to be a part of R3 or to belongs to V. Find the set of values ABC that UVZ is a basis for R3. Also, in a similar manner, get the determinant of the three vectors and to show that it's not equal to 0. This is how to get the condition. So all I need to do is to be sure that this set XYZ is a basis for, I think they are linearly independent vectors. So if I just get this form, which is vector 1, vector 2, and for the last vector, trying to open this vector or to get the value of this determinant. So I will end up having 4 equal A plus C minus B. To have Z, or to be a basis for this system, this equation shouldn't equal to 0. Because if this value equal to 0, this determinant is not going to equal to 3, which means it will be less than that, which means that there is one of them depend on the other, so it can't be a basis. It's a very smart move, and it depends on the idea behind a determinant doesn't equal to 0 and the reflection on the system, as I told you. For this slide, you have this Python programming. You can check that on your computers, okay? And this is the exact results. Okay. Here's stating two questions. The first of them is about to see if it's true or false. And for these questions, please read them carefully. They usually be direct, but you will have to review the properties as I told you. If the null space of A contains non-zero vectors, then AX equal B can have a unique solution for some vectors over B. Okay, for some vectors of V. Let's repeat it once more. If the null space of A contains stop, the null space is the solution of Ax equals 0. And to have a solution, if the null equal to 0, I will have a unique solution, if you remember. But if the null dimension or the null space of A contains non-zero vectors, it means it contains vectors. These vectors are the free vectors. So you will have infinite number of solutions. Then Ax plus B can have a unique solution? No. If A contains any vectors, you are not going to have a unique solution. Remember this rule. If the null equal to 0, that means the rank equal to A, which means you will have a unique solution. But if the null of A doesn't equal to 0, so dimension is not going to equal to 0, so n minus A will be equal to some value, so you will have infinite number of solutions. So for this statement, no, it's false, dimension n A more than 0, then the rank will be less than n, then you will have independent, you will never have a unique solution for this problem. Okay? This is what I'm telling you about. You will never have it. Okay, if A and B are n by n matrices, and the A times B determinant equal to 1, then B is an inverse of A, not necessarily true. This is not necessarily true. You don't have a property telling you about this. And one of the smart moves in this example, I have A, which is a unit matrix. I have B, which is a unit matrix times -1. None of them is the inverse of the other, because the inverse of a unit matrix is the unit matrix, not the inverse, not the negative side of the principal diagonal. Although, if you multiply these two determinants, these two matrices, you will end up having a unit matrix with absolute beta equal to 0, and this is not correct. So, this statement also is not correct, as you can see. This is the end, I believe that's the end of this exam. I will go quick on the second exam too. It's a first session for final exam 22-23. Also, all the instructions in the first paper almost the same, so there is no difference in these statements. If I want to, what I recommend for this part is to have your pens with you. Please try to use a pencil. I can use a pencil in all times, but I would prefer using pencils with slits B or 2B and have a good eraser with me. Okay. For the question number 1, here identifying the answer booklet only, same blah blah blah. For the grades, the correct answer will be 1. If you didn't answer, it's going to be 0. If you answer a not correct answer, you will have a penalty of 0.3. Here, let's A and B be an n by n matrices. The expression A minus B to the power of 2 minus A to the power of 2 minus B to the power of 2 is equal to. And he's giving you 4 alternatives. Actually, this question is tackling the multiplication of matrices. So all I have to do is to try to expand A minus B to the power of 2, which is going to be simply, if you try to do so, it's going to be A to the power of A times A. So if I want to multiply in a language of matrices, so it's going to be A minus B times A minus B, which is going to be A times A times B. So you will have A dot A, then you will have a minus for A dot B, then you will have a minus B dot A, then you will have a plus of B times B. That's A times A, B times B. But he's telling you that you have negative of A squared, negative of a B squared. These terms will cancel those two parts. And this is going to leave you with this part. So which one is the right answer? I believe it's going to be A is the right answer. So all I have to do is to expand the relation, taking in mind that multiplication matrices is not commutative. For this problem also it's very, very nice. You have a matrix which is 4 by 4, and he's asking you about the determinant of this matrix. But just a quick remark. If this is the principal diagonal, This is gonna be a lower triangular matrix, or our triangle. Okay, let's rearrange this matrix. It's gonna be really, very simple. Okay, for a determinant of this matrix, if this matrix is equal to A, so the determinant of A, okay, let's switch rows. So if I switch the row, moving this row to the upper one, so I will have A, X, Y, and Z, okay, which is going to be the negative of this fellow because I made a change. This one is going to be 0, 0, 0, and D. And also, if I make another switch, which from the second to the third, so negative sign will be once more be positive, and I will have 0, B, R, and S, and instead of them 0, 0, and then C and T. Now I have a lower triangular matrix. I told you, you will have to read the properties of matrices very carefully, and the determinants also. So really, it's really very simple to find that the value of this determinant is going to equal to A times B times C times D. So as I told you, the right answer will be A, B, C, D as we did. Okay, so it's going to be number B as I told you, which is a very simple question also, but just to remember the properties of the determinants. I told you that it was not, these properties are really very important. Okay, for this problem, he's telling you that I have A minus lambda I, which is look like a characteristic equation of a certain matrix in order to get the eigenvalues. He already analyzed it for you, lambda plus 5, lambda minus 6, lambda plus 8. Which proposition, okay, is false? Which one of them is not correct? Take care about this. So you have to read really, very carefully. Okay, A is a 3 by 3 matrix. Okay, A is invertible. Stop. Once I have these values, A 3 by 3, it must be a 3 by 3 matrix. So this is correct. This is not what he is searching for. A is invertible. Yes, it's going to be invertible since you have these values. A equal A squared. A is diagonizable since you have these eigenvalues and they are different than each other. So this one also is correct. It's going to be, of course, invertible since you have certain values for them. And there is no lambda equal to 0, so it is invertible. What's not correct or necessarily correct in this one. So the right answer will be number C. Stated for you by logic A is 3 matrix. Number 2 is invertible since you have different values of signs. As you have different values of eigenvalues, it is diagonizable, so it all makes sense. Here for the last one in the multiple choice, is asking you about the span U, V, and W, which is a subset from R3, and he's giving you the condition for a specific condition, F3U minus nu plus 2 omega equal to 0, and omega doesn't belong to the span of V, so omega doesn't belong to the span of the V vector. Which proposition is this necessarily true? Okay, let's go through them. S belongs to R3, maybe or maybe not. So if there is a difference, or it's not necessarily true. W is a basis for S, we're not sure about that. So if U and V is equal to 0, or the formation of W, we are not too sure about it. Also, V and W is a basis for S, may work, it may not. But what's impossible to happen is to have this condition which states that W will equal to 0, W doesn't equal to 0 for sure to have this statement true. So the only alternative that's necessarily true is A, as you can see. Okay, once more a similar problem to the problem that we did go through in the previous session. In the previous exam. He's giving you a system of equations and he will ask you some questions about it. Classify the system as a function of A, which is really very simple. All I have to do is to put the augmented matrix, which is 1A1, 1A, 1A equal, and the line 1, 3. This is going to be the augmented matrix. try to reach to a reduced echelon form. This is the augmented. I will try to get the reduced echelon form, and then you will find the condition. First, if A equal to 0, and if A equal to 0, you will have no solution. If A equal to 0, you will have no solution. This element is going to equal to 0. That means the dimension is going to be 2. But this, when A equal to 0, this is going to be remain with you. So the rank of the augmented matrix is 3. So they are not going to equal to each other. So you will have no solution. Okay. Dependent for A, if A equal to 1, you will have a dependent solution. If A equal to 1, this is going to be a complete 0 row. So the ranks of the A matrix and the augmented will be 2, and then you will end up having infinite number of solutions. Okay. He's asking you when A equal to 0, find the basis for the null space of the coefficient matrix. The null space is really very simple. What I have to do is to solve the system, but with the B equal to zeros. So I will start by putting these elements equal to 0, x, y, z, y, z equal to 1, x and equal to 3, and I will try to solve this system for a homogeneous part. This is going to be the shape of your matrix, which is going to lead to this result as a reduced echelon form. That's x equal to 0 and y equal to negative z. So once you try to substitute in the solution z, you will end up having 0, 1, and negative 1. Okay, when A equal to 1, find the matrix of the same size and with the same rank of the augmented matrix of the system, but not row equivalent to it. All I have to do is to make these substitutions, and you can do a lot of things. The simplest is just to move or switch these two rows, two columns together. So instead of having 1, 0, 2, I will let this one to go to the fourth column, and this to be to the third, and it's all satisfied. Okay? When A equal to 3, and then I will find the value of x in the unique solution of the system. If I put A equal to 3, you will have a 3 by 3 system, which can be easily solved, and you will find that the value of z equal to 0. This is the last equation, so 3z equal to 0, which leads to z equal to z. Z equal to 0, and you can substitute back and get the values required. Let A, this is really a very interesting question also. It's giving you A, which is 1, -2, -2, and 5. And this is AB multiplied in each other. They give you the B matrix. He's asking you how many rows and how many columns have the matrix B. Okay, let's think about that. Yes, it's an A times B, so it's a 2 by 2. I have to put here 2 times 3. Yes, 2 times 3. So actually the first answer is 2 by 3, which has a 0.5 out of 10. If CAB equal this value, C, it's a new matrix introduced to you right now. You don't have any definitions for C. So all I have to do simply is to consider C as a set. C1, C2, C3, C4. This is the matrix. If you multiply this matrix by this system or by this AB, you will get this result. Actually, I have a number of equations and number of unknowns. So if I multiply the first row by the first column, I will have an equation in C1 and C2, and it's equal to positive 1. And same way, like if I multiply the first row by the second column, the result will equal to 2. That's 2 equations in 2 unknowns. Solve them, you will get the value of C1 and C2. In a similar manner, if you multiply the second row by the first column, the result will equal to 2, which is an equation. Multiply the second row by the second column, is going to be the second equation. Solving them together, 2 by 2, you will have the results of this C matrix, which is going to come up to this way. Okay, now I have C1, C2, C3, C1, C2, C3, C4. I'm sorry for the typo. This is C3. Okay, which is this matrix. Multiplying this matrix by A and B, the result will be 1 and 2. And from here, I can get the results of A and B. As I told you, now we can multiply the C matrix in the AB column, should equal to the final column 1 and 2. Once more, I will multiply the C matrix by A and B. The result will equal to 1 and 2, whose augmented matrix is a row equivalent to this matrix. Okay, very good. For group number 4, he's giving you B, which contains 2 vectors, C, a basis. For subvector space, you have a vector and the other vector is unknown. Let X be 2 and 1. And he's asking you, show that B is a basis for R2. How to show that B is a basis for R2? They should be linearly independent, okay? And once they are linearly independent and contain the space of X and Y, so it is AB has 2 linearly independent vectors, so it is a basis. Number B, find the coordinates. All I have to do is to, once more, if you remember, this is 2 and 1, which equal to alpha 1, alpha 2. This is the first, this is the second. The first is 1 and 2, the second is 0 and 1. Solve them in order to get the values of the coordinates. So question number 2 is very, very simple. This is, as I told you exactly. In order to get the corresponding coordinates, all I have to do is to solve this system. You will find alpha 1 and alpha 2 equal to and negative. For the C, or for the third, I've wrote it here for you. FC is also a basis for R2. Find the V, so that this is really a very clever question and very simple too. Okay, and the V, so that the coordinates are the same. So I will use exactly the same manner. Having the coordinates, which is 2 and the negative 3, and allowing any variables stand for the subvector space C. So I will have 2, okay, times 1 and the negative 1. This is the coordinate of the first vector. Negative 3 times the unknown vector, which equal to 2 and 1. Just try to solve it and you will find the value of V in front of you, really very simple, 0 and the negative 1. This is a Python question. Just go through, try it on your computer. It's very, very simple. So the direct will be in front of you easily. Okay. And this is for the final problem, which is about, once more, dynamical system. You have an A, which explains that I have a bunch of vats, and these vats will split between 2 caves, 1 and 2, exactly like the previous problem. This is the matrix. So this is from cave A into cave A, from cave B into cave A, from cave A into cave B, from B into B. And this way, you will be able to get the questions about the bets. Okay, we can diagonalize A. In order to diagonalize A, just to check what I told you previously, the sum of, or the trace of this matrix is going to be 1.5. The sum of each column, which is going to come up to 2. So one of the lambdas is 1, and you have the result 1.5. So the other lambda is going to equal 2.5. Making the substitution, you will get the solution. It's a very direct question. I'm telling you here that the sum of the columns equal to 1, so it has to be one of the lambdas. The trace is 1.5, so the other value will be 0.5. Now I have 0.5 and 1, and this stands for A. This is the proposed B matrix. I'll get it from using alpha equal to the eigenvalue equal to 1, and I've tried to solve this problem once more. If you don't remember this, it's gonna be 0.7 minus 1, for example, 0.2, okay, which equal to 0. This is gonna be 0.3, then 0.8 minus 1, okay, and you will end up having a system which is 0.3, 0.2. Exactly the same for the second term, which is going to be 0.3 and also 0.2. Eliminating this part, you will get the condition which will be for these 2 eigen values. Same way like, okay, if the entry in the long run, so I will need to get also the steady state condition, which means that you will take the limit for the matrix, which is half and 0, so you will end up having d to the power of t times p minus 1, and this is b. So it's going to be 0, 0, 0, and 1. This is the main matrix. This is the main matrix, okay, with the power. Okay, here we go. This is the AT matrix after you take the limit, as I told you. This is xt, which is AT times x naught. AT, we already made a diagonalization, which is b dt, b minus 1. Taking the limit to infinity for dt, it will deliver the final result, which is going to be 0, 0, 0, and 1, as I told you. Multiplying by b and the p minus 1 times x naught, you will get the value, which is 400 and 600. Okay, also really very simple, and this is for the movement. For the last question, he is asking you about, okay, if the entry A21, second row first, which stand for 0.3, which means that 30% of the bats from the first cave will move into the second cave. I have also written it for you and relative to the terminologies or the scenario of this problem. This is cave 1 to cave 1, cave 2 to cave 1, cave 1 to cave 2, cave 2 to cave 2. So the last comment will be exactly as I told you. Also, you have two questions as right or false. Let's go through them in order to finish this exam. He's telling you if A and B are row equivalent matrices, then their eigenvalues are the same. Nope, it's not correct, because simply if I have 1, 0, 0, 1, 1, 0, 0, 2, if I multiply this row by 2, it will be a row equivalent. And the eigenvalues here are 1, and the eigenvalues on the other one is 1 and 2, so it's a false statement. If A is similar to B, and the B is similar to C, then A is similar to C, yes, this is true. If A is similar to B and A is similar to C, so applying these statements, that means A is similar to C, and it is true. Guys, bottom line, all I need you to do is to just review your course very well, just go through it as quick as possible, try to grasp this information, try to be calm. As I told you, you have to sleep well, study well, and have a good sleep before exam in order to keep your mind working as good as possible, and be early in the campus for your exam. Best wishes for you all. Thank you very much for listening to me for this session. I appreciate it so much. I'm sorry that I'm trying to be fast, but actually the time is running. They have other classes today, so I wanted to have you to hold this video for you ready on this time and as quick as possible. Thank you very much, and wish you the best of everything. Thank you. Bye.